Hannah here, and I'm going to talk to you today about our assorted Composing Polygons and Polyhedrons kits. In front of me I actually have 5 different kits that all are useful for discovering geometry. On my right, I have our basic Composing Polyhedrons kit. This consists of an assortment of regular polyhedrons as well as pyramids and prisms. Then we have our geodesic sphere kit. This is an expansion that's a standalone kit to the Composing Polyhedrons if you want to talk about engineering design and decomposing shapes within a sphere-like shape that is made of all flat sides. In the center here, we have our Composing Polygons kit. This is really useful for a variety of two-dimensional explorations, and I'll get into more depth on that one later. Then we have our Composing Polygons kit Tesseract expansion, and this one is actually about a hypercube, which is a 3-dimensional picture of a 4-dimensional object. So you can do some interesting higher level mathematics with that. And then finally we have our Composing Polygons kite expansion over here, which gives the students a chance to integrate science, go outside and have a lot of fun designing and flying kites, all while discussing surface area, volume, and an assortment of other geometry concepts. So let's start with the Composing Polygons kit. You do a lot of interesting challenges or tests for your students. For instance, you might challenge them to all build a triangle. And then you can get your students to take the measurements of the 3 angles that are in their triangle. This will lead them to starting to understand that all triangles, the sum of the interior angles is 180. And then you can keep expanding that and have them do the same thing with quadrilaterals or pentagons. And they're using the inquiry method to start determining the formulas that dictate that. Other challenges you might give your students would be to give them a single right angle with 2 congruent side lengths and ask them to build a quadrilateral or a triangle. A really good chance in middle school to then start talking about side angle side and giving your students these requirements where they then have to figure out the rest of the polygon. Or you could challenge them with impossible things, such as giving them 2 right angles and asking them to build a triangle. So the students get a good chance to explore both what is possible and what is not possible with polygons. And then you can start getting them and pushing them into classification of these polygons. For instance, with quadrilaterals, this is a good chance to practice parallel and perpendicular lines. For instance, if you were to tell students they had to create a parallelogram, but that they weren't allowed to use right angles, they would then have to discover on their own the angle requirements to create a parallelogram. Now let's move from 2-dimensional to 3-dimensional. Our Composing Polyhedrons kit is really useful for students to explore similar shapes and congruent shapes, and you can do the same with the Composing Polygons kit. But this one, you could do it in 3 dimensions. This is a good chance to integrate edge length versus volume, and the students are getting to calculate the volume of these complex shapes. They're doing a lot of practice with that, and it's all hands-on. In addition to doing volume calculations and looking at similar and congruent shapes, you can also use our Composing Polyhedrons kit to start having the students discover on their own Euler's formula for the relationship between sides, vertices, and edges. This is a hands-on experience with the shapes where students can actually physically see them instead of just pictures in their books, so that they can go through and count all of those things and then start developing the trends, seeing the trends, and understanding and deriving the formulas for them from the objects. Additionally, with both the Polyhedrons kit and the Geodesic Sphere kit, the students get a chance to see how some basic shapes are seen in real-world architecture. This is tying it into engineering, this is tying it into understanding how these shapes are used in the real world. Specifically with the Sphere kit, this is a very solid, sturdy shape that engineers use regularly because of its stability. And so students can start exploring that and doing engineering tests on the models they're building. And they can see how an object like this is significantly sturdier than one like this, even though they're vaguely both spherical. And so it's getting a chance for the students to actually have hands-on interaction with complex geometry. Then, to expand that even further into more engineering and more science, let's take it over to our kites expansion. Now this is a lot of fun. They design their kite, they design how much of it they want to cover with paper, and this can get into dynamics and the force and the pressure of the wind and how you would design a kite to be the most effective in the air. And then they get to go outside and test it. So while you're having them calculate the surface area to build these sort of nets around the geometric shape, the students are then getting a chance to talk about surface area in relation to volume. Does covering more surface area of the kite assist in its flying or not? Is there a good balance there? So it's a lot of sort of open-ended experimentation where the students are playing with different amounts of vertices, different shapes, and they're going out to see how well they actually do when placed in a real-world scenario flying a kite. With these, you will need to hot glue the pieces together or they will break apart the second you try and fly them. If you're using hot glue, simply apply it to the end of the vertex piece and overlap the edge just a little bit so that when you slide the straw on, it goes the full length of the straw and holds it more securely. So whichever one of these kits you choose to use in your classroom, we hope you have a blast with it, and we know you're going to have a lot of good, fun interaction with the students where they're building, they're designing, they're figuring things out, and they're really having a blast with geometry. Thanks for listening and have a spectacular day.